Alrighty, so here we are back to see what the configuration of this would look like to hook this up. So this makes a few assumptions. You've already got a Kubernetes cluster deployed. You've already got Argo CD installed into it. And so we're not going to show that portion of it. Let's presume that you've got a mostly vanilla setup in that sense. And how do we actually get notifications set up? How do we actually set up the GitHub Actions and the triggers? How do we set up the cluster doctor and run its own pipeline? And what are the actual tokens or credentials do we need in order for this to be set up? So I'm going to try to walk through this in an orderly fashion. And so first, we're going to walk through the Argo CD notification system. So here's Argo CD dashboard. We're not going to go in this view. This is, again, just a level set from before. You know, how do we, when this is like when an order service like this or a make line service, when it degrades, how can we get Argo CD to emit an event? So in the repo that we've already provided, under Act 3, Argo CD, there's this Argo CD notifications config.yaml file. Now, within here, there are a number of things going on. There is a config map. So this is essentially an entire config map. Here's some data in here in terms of the service, the webhook that we're actually going to call. Here, you actually specify, follows a common pattern here, API, GitHub, repos, the org to which the webhook is going to be sent to, the actual repo, and then the dispatches related to it, right? Okay, good. What does this look like? How do we actually send authorization to it? Because we don't want anything to just be able to call that particular endpoint and trigger a webhook into it. What we want is the actual pass this GitHub token into that environment, right? Which is going to be a PAT token in our case today. It could be a GitHub app identity token as well to be passed in. Basically, something has to have the right authorization and an authentication token to be able to call that service, right? And so we can generate that in a moment, and I'll show you that. But again, this is how it knows passes in. And this is going to end up being a secret that you create within the namespace of this notification, which is Argo CD in our case. All right, once we have that, so that knows how to trigger the endpoint, where that endpoint is, what the credential or the HTTP headers will be for it to trigger. Now we want events to be triggering on. So in this case, we have two. We've got in case the synchronization fails for the repo, or in case the app itself, the Argo app itself, the status ends up becoming degraded. Okay, so one of those two conditions must be met. When it does meet, what we want is to send that webhook. So we've defined this GitHub webhook, right? It's going to line up here with this GitHub webhook itself. So GitHub.webhook, GitHub-webhook here, and it's going to be a post method. We can define the information to send. Now this information has to be accessible by the actual Argo CD app itself. So .app, and then all the metadata and all the other data that is available to it in that space. So what we can do as a result is be able to pass it metadata about the namespace, the sync status, health status, et cetera, which repo it is corresponding to, and so forth. All right, and so all of this gets sent as a request to the actual GitHub action. So if we take a look at the GitHub action, if we go to the .github directory in our repo, if we go to workflows, if we go to, this is the Argo deployment failure, this is the workflow that it triggers. And what you'll notice is, I'm going to go in reverse because I failed to show that earlier. It only responds to repository dispatch, or basically webhooks that are called in with this type associated to it as part of the call. So if I actually go back to the Argo notification itself, and if we scroll down here, the event type Argo sync failed should in fact match up if I didn't mess this up. There we go, we got the right file. Argo sync failed here. All right, so all other types of requests do not get triggered by this pipeline. At least you can create other ones that do get triggered by different types. But this one only gets triggered if, again, something has the right authorization to call pipelines in this repo, and also has this particular type as its request body. Okay, so we immediately are able to filter off that. Now, this particular pipeline is going to end up writing an issue, so we need the permission to actually write issues. So this is how you scope a GitHub action. A GitHub action has its own token. and its own ability to do things within the repo, and so it can write. And it can also write contents, which is code, to the repo itself. So this is important because there are other things that are dependent on this later on. Okay, so from here on in, we have a step that runs a GitHub script. It's like a JavaScript-like language, essentially, which allows us to parse through the actual payload that came in that triggered this event. So the payload being the Argo CD notification with that body object that we sent before in the notification config YAML. And what we can do here now is parse through it in this script. Okay, add some conditioning. That's not super important. You can read through that later. And then actually start generating or creating the title for the issue, and then start building out the issue body itself. All right. There was an example prior to this that we would use GitHub Copilot CLI itself to parse through the object and then to synthesize what this issue could look like. I mean, that's one method, but that does consume, of course, GitHub Copilot, what we call a premium request unit today. Basically, it has to call GitHub Copilot, so that's another thing that's going to cost you. But this is a very deterministic way of following it. This is not going to change that much, and if you modify it, it's not that big of a deal. So it's not like it's going to be a nasty different body payload each time you trigger this. It's going to be fairly consistent over time. So let's just deterministically, or write it through a script and just generate the body of the object itself. Okay, so we post the issue, and one of the key things about this one to actually trigger it automatically is that the condition here when we actually create the new issue, so in this function here, await GitHub rest.issues.create, we're also going to create a label for this issue. Okay, so we got multiple labels here, and the most important one here is this cluster doctor label. And so we have another pipeline that gets triggered whenever an issue is created with this label associated to it in the same step. Okay. Note also that we are able to modify the dispatch event to that other repo. We can omit some other details like the event type. So if we want to further filter on that, again, kind of the same thing, where if issues or we want to trigger another pipeline and the event type is a custom one, we could do so if we wanted to. Okay, and we also pass in the issue in the body of that payload. All right. So with that, once it creates the issue with the automatic label, of course, what we're able to do then is to automatically trigger this cluster doctor pipeline. And so it kind of does the same thing, right? It runs if and when the workflow dispatch is run, so we can manually call it. If repository dispatch, which is basically a webhook, gets called, then it can also run. And then we also check to make sure that label of cluster doctor is in there. We have some other conditions, just double checking that we are in fact running whenever that label is applied. Okay. All right. In this workflow, we're going to have to do a few things. Okay. You're going to notice a couple of different changes. First off, we actually have to pass in some environment variables here. We've stored some secrets in our deployment environment, and those are going to be used for workload identity federation with Azure. Because our Kubernetes cluster lives in Azure, we can create a managed service identity in Azure itself. And what we can do now is whenever we log in with the Azure CLI, and we have to include this, I forgot to highlight that, the ARM use OIDC, true. This tells the Azure CLI when we do a login that we're going to do a token exchange for the identity of this particular workflow. And so what will happen is that the GitHub action itself, based on the environment that it's running in, and it's running in the environment of Copilot, I'll show you that in a sec, it will say, hey, I've got this signed token, I am this entity, it's signed by GitHub, give me a identity that exists in Azure that can do Azure-y things, right? So all this, along with the Azure CLI, will do the exchange. The GitHub action gives it its token. Azure returns an Azure token that can then run commands against Azure. Okay, so what does that look like then? Okay, so if we go to Azure, you'll notice that I've got this managed service identity. I can then go into federated credentials, and then I can add credentials. And that'll walk you through how to add the repository name, the environment, maybe you want to trigger on a branch or something like that. There are other configurations in there. But this sets up, and this is my own custom configuration. I named this myself here. Under issuer, this says, okay, which is already baked into the federated credentials step-by-step process. I'm not going to run you through it because I don't want to expose tokens and values. But here it basically says the signer, the issuer of a token coming in from GitHub is going to be signed by this this authority, and then the subject identifier, the entity to which it should be signed as, is the repository, Microsoft GBB. It's going to be the organization Microsoft GBB, the repo of Agentic Platform Engineering, and then it's going to be calling via the environment called Copilot. All right, and so if those things match, because it's been signed, Azure will then give back a token that is scoped for Azure and can do Azure work as a result. So nowhere in here anything secret has been stored, meaning there's no API keys or anything like that. Here, just in GitHub environments for Actions, you'll see that the ARM client ID is stored in here as an environment variable in the Copilot environment, the Azure subscription ID, and the tenant ID. Now, I've saved them as secrets, but they're not super secret, meaning if they get exposed, it's not great, but it's not horrible, right? It's not like I can leak the actual auth token into the environment. So it's okay. This is just use this information to identify, hey, which environment am I targeting? Okay. For the keen eye, you'll notice that I also have another repo secret, which is a GitHub Copilot CLI token. This is the token that we will end up using to call GitHub Copilot. Okay. And the reason for this is because a GitHub action today, as of 11th, we cannot actually via GitHub action call GitHub Copilot CLI. That'll change in the future, right? But just today, March 11th, 2026, we can't do that. All right, so in order to do that, we have to create our own GitHub Copilot CLI token in order to call it. So the question then becomes, okay, how do we actually get this CLI token? All right, under your own account, we go to settings, and we scroll down to developer settings. You can create personal access tokens. Now we want to create a fine-grained token, not this classic token, which gives us too broad of a scope. We can actually click fine-grained tokens, and I already got a few already in here. I'm just going to walk you through creating one. So I'm going to create this one, and you give it a token name and descriptions so that you can follow it. This is going to be bound to you. So this is because GitHub Copilot CLI today is issued on a per user basis, and so your ability to call GitHub Copilot is bound to you, your license as a user. Okay, which is why GitHub Actions cannot call GitHub Copilot CLI because it's not a user, and you can't assign GitHub Actions a license, etc., etc. All right, I digress. The thing that you need to note is that we generally need to scope it for like all repositories, not only select. You actually want to hit your account permissions, and what you want is Copilot requests itself. And once I select that, you'll notice that there's only really one option, read only. So this allows you to gain access to make Copilot requests. All right, I hit generate token. I'm not going to do that here because I don't want you to screen capture my my tokens. But once that gets generated, you'll get a token that you can copy and paste. That'll only be showed once. Okay, keep that in mind. So you want to copy it right away. Then you want to go into your secrets. I already went past it. So let's go back to Action Secrets. You can edit this as an example, and then drop that token value in here, and it'll use in this pipeline. I'm not going to do that here because I don't want to overwrite my CLI token, but then it's available. Okay. Now, if we go back to I think it's here. All right, if we go back to the workflow now. So that was all setting it up so that we have the ability to federate our credentials with Azure. We now have the ability from a GitHub Action perspective to write ID token. This is needed in order for us to grab and federate our identities with Azure. We can write code back. We can write issues. We can also create pull requests now. So this is scoped to the GitHub action, this workflow that we'll run. Okay, we've got filters to make sure that we're running. We're going to check the issue body for information. We're going to parse some stuff out. Okay, not super important there. We're going to install the GitHub Copilot CLI. So this actually installs the NPM package to run GitHub Copilot CLI. That'll likely be part of the environment in the future. We don't have to do that manually. Now what we want to do is to be able to parse a few things. Okay, note that for running GitHub Copilot CLI today, again, we're going to have to pass in 2 different tokens. The first one here is going to be a token we use for the GitHub MCP server. So if we want the GitHub Copilot CLI, or GitHub Copilot, to be able to interact with GitHub itself via MCP, it's going to need an identity that has that kind of scope. And so what we're going to pass in here is the secrets.github token. So this is the GitHub Actions token. So what we set up here in terms of permissions, what it's allowed to do when running in this environment, okay, are those permissions. And so, I lost my spot here. Let's go back down here. This now allows, whenever the GitHub Copilot CLI or the agent we're going to run later on via MCP, to actually write issues, create PRs, and commit code back to our repo. The second thing we need is the GitHub, in this case, the GitHub token. So this authorizes our requests to GitHub in order to use the GitHub Copilot CLI to make GitHub Copilot requests. And so you notice this matches up to the secret we generated, the token that we generated and saved in a repository, but we're mapping it now back to the GitHub token environment variable, which under normal circumstances would be this one, but we have to do a little bit of trickery today because, again, the GitHub action itself does not have the authority, the authorization to actually call GitHub Copilot CLI. So that's just a point in time today, Wednesday, March 11th, 2026. Okay, but we're doing this so it wires it up. So when I run the GitHub Copilot CLI down here, all right, this automatically looks in the environment for a GitHub token to authorize it to make calls to GitHub. In this case, authorize it to make calls to GitHub Copilot CLI. And then inside our MCP configuration for the GitHub MCP server, we're going to specify that it uses a different environment variable, this GitHub MCP token, so that I can make calls to GitHub on our behalf for all the issues and the PRs and the code commit back to the repo itself. If we go into this folder where we saved it, .gopilot MCP config JSON file, this is where we've rigged it up, right? So again, the GitHub MCP server, it's going to call this endpoint for GitHub Copilot MCP. We're going to allow all the tools, and then we're going to set the authorization token here to the GitHub MCP token, which we've essentially remapped. Okay. You'll also notice we have another MCP server configuration here. This is for use in our script to allow GitHub Copilot to call an AKS MCP server hosted in our AKS cluster to do some additional diagnosing and triaging of the cluster itself. All right, we'll go back to the cluster doctor. Okay, so we jumped ahead a little bit in terms of how GitHub Copilot is hooked up, how it actually does the call on our behalf, right, to GitHub. What we didn't describe was how do we actually what are the steps required for federation. So here you'll notice that we have federation to Azure, that is to say. Here you'll notice that we have the client ID, tenant ID, and subscription ID for the Azure CLI login. Okay, with the other environment variables like OIDC login set to true, this tells the Azure CLI login command to do the token exchange for us based on this information. Okay, we just do a sanity check to make sure that it can authenticate and it connects. We're going to then install all the Kubernetes command line tools that we need, kubectl command line and the kube login command line that does the actual token exchange for us for Kubernetes config. All right. Then we run the AKS get credentials command, which gives us the credentials for the Kubernetes cluster itself. The managed identity that I showed you earlier also has the ability to do configuration changes against the cluster itself as well. You may want to scope that down, give it read-only. It's up to you. It really is meant for you to use it in a well-scoped manner. So if you only want it to read information from your cluster, you can set it up for that ability. If you want it to also do cluster administrator type roles, you can provide it that capability as well. Up to you. All right. What you'll also notice is that we're going to be port forwarding to our MCP server on port 8000 here. This gives, again, GitHub Copilot the power to call our AKS cluster to get additional information via the MCP server itself. So if the issue body itself that was sent by Argo CD gives you just the minimal information, cluster name, what the possible problem is, you may need to run additional kubectl commands to get access to the cluster, to get more information, or to maybe change values if you want to directly modify it. Again, it's up to you, but that port forwarding allows you access to that MCP server, so important there. Okay, so I showed you earlier that, in fact, we are doing some remapping of these values that allows Copilot to then call the cluster, but from here on, it's essentially all just within the prompt that we have. So we're interpolating this variable, which we build the prompt, what we want it to do, some additional instructions in here on this line. Okay, we'll pass in the GitHub issue, the repo name, and some other valuable information. And then we allow it to use, or tell it to use, this cluster doctor custom agent, which is in the agents directory, .github agents, and this cluster doctor.agentmd file. You can take a look at that. That describes what mode or what kind of custom agent persona and rules that it must abide by in order to run in this particular mode. Okay, so that line there tells it to use that custom agent mode. We pass it configurations for MCP servers to run. In our case, we only have two, the GitHub MCP and the AKS MCP servers. Right? So that provides connectivity, how to contact the endpoints, the credentials it may use, and then we allow it to just use all the other tools in the repo, okay, or in its environment, or what other tool calls it has the capability of accessing via the command line. All right, and so with that, that's the low-level configuration that you need to know to get started. Should you have any questions, please leave a comment. You can even go back to the repo itself here, Microsoft GPB Agentic Platform Engineering. Okay, right here. Leave an issue. If you want updates, we'll be modifying the documentation to make it clearer. But these are the high-level steps to set up the PAT tokens that you need in order to contact the cluster, etc. All right. Yeah. That's it. Thanks for watching.